h of x, plus, leave that one alone, h prime of x, and then don't forget the minus 6. T prime of 1 is then g prime of 2 times h prime of, oh sorry, that's h of 1, plus g of 2, h prime of 1 minus 6. G prime of 2 we just found is 6 times 2. H of 1, so this is just the function value, h of 1 is 1. Plus g of 2 we already found is 5. H prime of 1, getting derivative from a graph is just the slope. This is the slope of negative 1 minus 6. So this is 12 minus 5 minus 6, that's 12 minus 11, so t prime of 1 is 1. Finding d prime of 1, so d prime of x, chain rule, g prime of x squared plus x times 2x plus 1 minus f prime of x squared minus 1 times 2x. D prime of 1 equals g prime. 1 plus 1 is 2. 2 plus 1 is 3 minus f prime. 1 minus 1 is 0 and 2. G prime of 2 is the 6 times 3 minus f prime of 0 is 7 times 2. So you've got 18 minus 14 is 4, and that is your d prime of 1. R prime of x, this is chain rule, f prime of g times g prime of x. R prime of 2 is f prime of g of 2 times g prime of 2. F prime g of 2 is 5, g prime of 2 is 6. F prime of 5 is 0.5, so then that is 3. R prime of 2 equals 3. And lastly, we've got a quotient rule. V prime of x is low, d high minus high, d low, underneath the low squared goes. So then v prime of 1 is h of 1 times 3 minus 3 plus 1 is 4, h prime of 1 over h of 1 squared. H of 1 is just 1. H prime of 1 is the slope, which is negative 1. So then it becomes 3 plus 4, which is 7 over 1. So that's just 7. V prime of 1 equals 7. Alright, this one, so we're talking about rates here. We've got rainwater flowing into a pipe, and we also have water flowing out or draining, going away. And then this is our initial conditions, right? This is how much you have at time equals 0. So I want to know how many cubic feet flow into the pipe. So into the pipe is talking about R of t. So A would just be, this is a rate, so I'm going to take the integral of the rate to get how much actually changed. So I'm going from 0 to 8 of R of t dt, which is just 0 to 8. R of t is the 20 sine. And this one is a calculator part, so we just go to our calculator. Math 9, 0 to 8 of 20 sine x squared over 35 x. So this one I get 1.70198. Make sure you put enough decimal points for free response for calculus. They expect at least 3. Oh, I did this wrong. Why did it? Oh, my calculator's in degree mode. Has to be in radians. So I'll remind you guys before you take your mock, but it's got to be in radians. Alright, so then this should be 76.57035. So you have to write at least 3 decimals. So good practice is just get used to writing 4. So then this is approximately 76.57035. Well, you don't have to write any more than that. That would be a little crazy. And then let's go ahead and put our, I already said cubic feet, so I don't need to put units. Alright, how many, is the amount of water in the pipe increasing or decreasing? So here, remember we have the rates that the water is changing. Because at first I looked at this and I was like, oh, I just need to take the derivative. But remember, I'm not asking about the like how if the rate is increasing or decreasing, in that case I would take the derivative, right? The derivative of r prime would be the rate at which the rate going in is changing. But I want how much the water in the pipe is changing, if it's increasing or decreasing. This is my rate in, and this is how much is out. So I made a note. I said r of t is the rate in. I said d of t is my rate out. Now I have a calculator, so I can find at t equals 3 what r of 3 is and what d of 3 is. So I'm just going to go to my calculator. Actually, to make my life easier, I typed in into y, so 20 sine of x squared over 35. And this one is negative 0.04 x cubed plus 0.4 x squared plus 0.96 x. Okay, now we're gonna do what r of 3 is. So r of 3 is 5.086, and d of 3 is 5.4. So if this is my rate out at t equals 3, and this is my rate in, notice that you're like losing more, right? You're draining out more than you're coming in. So at that particular moment, the amount of water should be decreasing because you have more coming out than you have going in. So I said the amount of water is decreasing at t equals 3 because the amount of water coming out is greater than the amount going in. So the rate out is greater than the rate in at that time. Oh, forgot to go back and do C. Oh, okay, let's think. When is the amount of water in the pipe at a minimum? Oh, shoot, I forgot to do that. I'm not going to go back in. I forgot to go back and do it. I'm not going to do it in a video. You can come in and ask me in the morning or at lunch on Monday. I skipped to D. So D, I said the pipe can hold 50 cubic feet of water before overflowing. For t greater than 5, the water continues to flow in and out at the same rates. We want to write an equation that involves integrals that gives the time w when the pipe will begin to overflow. So the pipe begins to overflow if the volume hits 50. So I want to know, okay, when my volume equals 50, that's the time that it'll start to overflow. Well, I have r of t going in, and I've got d of t going out. That's the rate, so I need to do integral from 0 to the time omega of r of t, right? That's going in, so it's a plus, and minus the integral from 0 to that time, some random time w that's just happening, of d of t. And then it's not just rate in minus rate out, right? Because I actually started with, how much did I start with? 30. So if I have 30 plus how much I've gained minus how much I've lost, once that hits 50, then I'll begin to overflow. So you can say 30 plus the integral from 0 to w. I'm pretty sure you can just leave it as r of t, but I'll go ahead and write it. Minus the rate out, which is the, oh, I should have just called it, the dt. I've already started, it's okay. So this is going to tell me this, whatever the time, 0 to whatever time w, at that point, once it hits 50, then that's when it starts to overflow. Right here, Joanna jogs along a straight path. I have her velocity at different times, and this is meters per minute. I want to estimate the value of v prime of 16. So v prime of 16 is going to be somewhere in here. I can't find the derivative at some random point, but I can find the average rate of change, which is an estimate of estimate of the derivative anytime between 12 and 20. So I'm going to use v of 20 minus v of 12 over 20 minus 12, because that's giving me the average rate the velocity is changing in this time, which is an approximation of the derivative in between there. So actually I'll write it down here. V of 20 is 240, V of 12 is 200. 20 minus 12 is 8. This is 40 over 8, which is 5. And I'm going to go ahead and put my units. I did meters per minute over minutes. That is meters per minute squared. Per minute squared. I guess you could have done meters per minute squared. Alright, that was A. Now B, I want to explain what the meaning of this definite integral would mean. So this right here, is, so absolute value of the velocity should be the total distance traveled. So this is the total distance in, we have to put our units because it says units, that's going to be part of the points, in meters. That Joanna jogs, and we need to tell the time, right? That's between 0, so between t equals 0 and t equals 40 minutes. Perfect. Now I want to actually approximate what that is using a right Riemann sum with the 4 subintervals. So right, I would be doing 200 times base of 12 plus 240 times base of 8 plus absolute value. So yes, it is negative 220, but I'm going to make it positive because I'm talking about absolute value. Base of 4 plus 150 base of 16. No calculator here, so boy, not work this out. Do what I did earlier. So this one was 2400. This one was 1920. This one was 880. This one was 2400. I added these two together and I got to 2800. These two together became 4800. Add those together and I finally got the 7600 meters. Approximation. C. So we've got a new function. It's Bob's velocity, and it's modeled. I'm gonna run out of room, so I'm gonna take one of these. So Bob's velocity is the t cubed blah blah blah. I want to find Bob's acceleration at t equals 5. So acceleration is just the derivative of the velocity. So that's going to be 3t squared minus 12t. The plus 300 will go away. So then acceleration at 5 is just 3 times 25 minus 12 times 5. 3 times 25 is 75. 12 times 5 is 60. So then that gives me 15. We're going to put our units. That's meters per minute. Oh, is it meters per minute? Yeah, meters per minute squared. Because Bob is still meters and minutes. All right, D, I want to find the average velocity. We're using the model from part C, so we're still using the velocity of Bob that was given. Average velocity of, average value of a function that you have is the 1 over b minus a, the integral of that function from a to b. I want to find the average velocity, so from 0 to 10, so 0 to 10 of Bob's velocity, 1 over 10. I'm going to do 1 over 10, 0 to 10 of Bob's velocity, which is this. And now we have to take the integral. Antiderivative of t cubed is t to the 4th, 1/4, minus t cubed 2 plus 300t, evaluated at 0 and 10. Don't forget you have a 1/10 out here. All of these zeros are going to go away, so this is 1/4, 10 to the 4th, minus 2, 10 cubed plus 300, 10, all of which has a 1/10 out front. Oh dear Lord. 10 to the 4th is 10,000 divided by 4 is 2,500, minus, that's 1,000, so 2,000. Plus 3,000, 1/10. That gives me 500 plus 3, so that's 5 like this. And then this is just 350, and that is going to give me average velocity, so that would be meters per minute. And last question. You guys should be super good on this question. We have a graph of f prime, and we're going to be answering a bunch of questions. I know that it has horizontal tangents here, here, and here. That means like these are the points where it like turns around. And it says the areas between -1 and 1. So this area right here is 9. And then this area right here is 12. Technically negative there, but we're good. Where do we have a relative minimum? So we're going to check where f prime goes from maximum, positive to negative. So that's x equals -2. X equals -2 because f prime changes from positive to negative. Done. Where is f both concave down and decreasing? So concave down is f double prime negative, which means f prime is decreasing. F decreasing means f prime is negative. So I want where the function is actually negative and decreasing. Negative and decreasing here, negative and decreasing here. So I'm going to say -2 to -1 and 1, 2, 3 because f prime is negative and decreasing. Here we're looking for points of inflection. So points of inflection is f double prime changing signs, which means f prime changes from increasing to decreasing. So we have here, here, and here because, so these two go from decreasing to increasing, the -1 and the 3. So x equals -1 and 3. F prime changes from, it was decreasing to now increasing. And then the other one is x equals +1 because f prime changes from increasing to decreasing. And we're trying to find the values now. So we know that f of 1 is 3. I have a graph of f prime. We're talking about the integral. Think about the integral of f prime is f. So if I want to do the integral from a to b of f prime of x, that would be the antiderivative of f prime, which is f, evaluated at b minus evaluated at a. So I have f of 1. So I'm looking, if I want to go 1 to x, let's call this t because it says you want to find f of x. This would be f of x minus f of 1, like this. The same idea of this, I'm just calling, I know a, so I know what I know 1, so I'm going to call 1a, and then I'm going to call the other one x so that it's not like f of some random thing, it's some function, or some value x. So then, I know that f of x is just this integral plus f of 1. So f of 1 plus the integral from 1 to x of the function. And you can't call it like x here because you're already saying x. Anyway, this is how you get f of x. Now I want to actually plug in and evaluate what f of 4 and f of -2 are. So f of 4 is just f of 1 plus the integral from 1 to 4 of the function. F of 1 plus the integral from 1 to 4 is -12. F of 1 is 3 equals -9 for f of 4. And then I need to do the same thing for f of -2. F of -2 is f of 1 plus the antiderivative or integral from 1 to -2 of f of t dt. From 1 to -2, you're working backwards, so this was -9, but you're going backwards, so it's +9. So this is 3 plus 9, which is 12. So these, the only trick here was you actually are used to doing this, right? You usually go from, you're used to saying 1 to 4 of f equals f prime, sorry. Oh my god, I would have gotten that wrong. I have to be super careful. You can't add f plus the antiderivative of f, right? It's the antiderivative of f prime, because when you take the antiderivative of that, that's what gives you f. Ooh. So this would be f of 4 minus f of 1. It's just rearranged for the f of x already. Okay, hope that was helpful. If you still have questions, come talk to me at lunch or in the morning.